A teacher wants to determine which instructional modality generated better student performance. The first column indicates online, and the second column indicates face-to-face learners. The output of each student is their average grade for a particular semester. For example, a student generated an average grade of 92 under online mode of learning, same as the next student who got 90 average of his or her grade. We have 100 students under the online mode of learning. Student number 101 got an average score of 86 under face-to-face mode of learning, and so on. We have a total of 200 students, 100 under the online and another 100 under the face-to-face mode of learning. The requirement for the t-test calculator for two independent means is that our data should be normally distributed. We will use the Kolmogorov-Smirnov test of normality to verify if our data is normally distributed or not. Let us copy and paste our data in the text box and then calculate. Our significance level should always be set to 0.05, so our computed probability value is 0.50483, which is greater than our significance level. If we recall, the computed p-value is greater than our significance level of 0.05, then our data is normally distributed. Let's try our data set for face-to-face learners to verify if they are normally distributed or not. Let's copy and paste. The result is 0.23771, which is greater than 0.05. So, our data set for online and face-to-face are both normally distributed. So we have now the basic assumption that we can use the t-test for independent samples. For this dataset, our objective is there a significant difference in student performance between online and face-to-face instructional medium? Our null hypothesis is there is no significant difference in student performance between online and face-to-face instructional medium.
To answer our objective, we can utilize the t-test online calculator for independent samples so that we can determine their probability value. So online learners is for treatment number 1 and face-to-face learners is for treatment number 2. Significance level should always be 0.05, which means that we allow the computation to commit at least 5% so that we can have the freedom for our data to behave as a normal way that they are in normal environment. Let us try to calculate. Our hypothesis should be two-tailed. Let us put our parameters here. Our significance level is 0.05 with a confidence interval of 95%. And then we have the results. Result number 1 would be the result for the mean of each treatment. For treatment number 1, the mean of the average grade of online learners is 88.42. For treatment number 2, the mean of the average grade of face-to-face learners is 88.36. In this case, online and face-to-face learners have almost the same means, having only 0.06 mean difference and having the same floor value of 88, which means that their performance do not differ despite of their difference in teaching modality. Let's take a look at their probability value. The t-value is 0.0814. We got a positive value, which means that the first group, the online learners, generated higher average grades than the second group, which is the face-to-face learners. However, we got a small value of t-test result, which indicates that our two groups are similar. Their p-value is 0.935209. Which is greater than our significance level of 0.05, which means that our null hypothesis will be accepted. Our data analysis will be the given dataset had been treated with t-test for independent samples since each group will consist of different participants or respondents. Each group had been tested with Kolmogorov-Smirnov test of normality with a result of computed p-values equivalent to 0.50483 and 0.23771 for online and face-to-face learners, respectively. These values suggest that the dataset in each group were normally distributed since their computed p-value is greater than the significance level of 0.05. Descriptive statistic result shows that the mean of the average grades output of online learners is 88.42, whereas the face-to-face learners generated 88.36 mean of their average grades. Having only 0.06 mean difference with a result of t-value equivalent to 0.0814, this indicates that online and face-to-face learners have similar performance. On the other hand, treating the two datasets with t-test for independent samples, it yields a p-value of 0.935209, which is greater than the significance level of 0.05. This implies the acceptance of the null hypothesis. Therefore, student performance between online and face-to-face instructional medium have no significant difference. The results of the study show there is no significant difference in performance between online and face-to-face instructional medium. This conclusion indicates teaching modality may not matter as much as other factors. Student performance may not be affected despite of online and face-to-face teaching modality. According to Daymont and Blau in the year 2008, online learners, regardless of gender or class rank, learn as much from electronic interaction as they do from personal interaction. Camp and Grieve in the year 2014 also found that both online and face-to-face learning for psychology students led to similar academic performance. Given the cost efficiencies and flexibility of online education, web-based instructional systems may rapidly rise. Furthermore, a study from Lorenzo Alvarez and others in the year 2019 found that radiology education in an online learning platform resulted in similar academic outcomes as face-to-face learning. This related study supports the implications of this study based on the analyzed data.